Welcome to Adding to the Cloud. This presentation demonstrates CloudFormation to beginners. We'll go over examples of how to use CloudFormation with Amazon's media services on the cloud. Now, what if we asked Alexa, how do I form a cloud? What would Alexa possibly say? Let's listen.
There are more ways than I can count.
Alexa may say, there are more ways than I can count. This is an introduction to CloudFormation. CloudFormation is a service from Amazon. This introduction has a few key points and exactly 5 hands-on demonstrations. CloudFormation is a service. It makes it simple to add to the cloud. Sometimes people shorten names. Shorter is simpler and more efficient. CloudFormation is also called CF. CF is simple for beginners. With CF, a user can form a cloud and reshape it over time. Developers write code for CF, and they can do so quickly and then efficiently execute that code on the cloud with this exact service, CloudFormation. Hi, I'm an independent software developer. My name is Alex. I work at SpicyKey, and I'm a passionate developer and a community builder. Welcome to this Reskill session about CloudFormation. There are 4 social media hashtags for this presentation. Please feel free to use these tags on Twitter and Facebook. These tags are the themes for this introduction to CF. These themes are transparency, reversal semantics, code semantics, and reusable parts. So let's go over the ecosystem around CloudFormation, and these are reusable parts. It's up to you to decide how much of this ecosystem around CloudFormation you use. But this is a beginner map of CloudFormation and what's around it. For example, S3 or Cloud9 or Systems Manager. All right, so if we were to ask Alexa, what does CloudFormation look like? Alexa is going to say, hey, it could look like code, like over here on the left, or it could look like a graph over here on the right. CloudFormation template is code. So what does it look like? Well, it's up to you. You can write a CloudFormation template in yet another markup language or JavaScript notation. It's up to you, but that's what the code will look like. Now, this code must be in an exact structure. The structure is simple and has a name, template structure. This is important. A piece of CF structured code is called a template. A template is extremely detailed. This template provides high levels of transparency. So this is why we talk about transparency as a benefit of CloudFormation. Hashtag for this slide is transparency. Now, CF code forms a data structure called a graph. A CF graph may be visualized by the CloudFormation service. For example, here is a simple graph of 2 resources hosted by one service. These 2 resources are media live resources, 1 channel and 1 input, and the channel refers to the input. So it's a tiny graph. And this is why CloudFormation code can look like a graph. The resources in a template can refer to each other. So here is the first demonstration about how to add to the cloud with CloudFormation code. Let's see what CloudFormation code looks like.
This is the first demo in adding to the cloud, and we're going to go over how to add to the cloud with CloudFormation and code. Here I am streaming on YouTube a video of asteroids. Isn't that neat? I am streaming this video with a service from Amazon named AWS Elemental Media Live. I added what was necessary to the cloud with CloudFormation. I added one channel and one input with CloudFormation code, and we're going to go over that code in a second. Now, there's something really important to remember. When we use CloudFormation to add to the cloud, it remembers what I added in a graph. For example, it remembers that I added a channel and an input, and it also remembers that the channel refers to the input. That's what this graph looks like. It remembers my resources and the graph in a CloudFormation stack on the cloud. So we can say that I created with CloudFormation template code one CloudFormation stack with one channel and one input. Let's go over that template code. This is a CloudFormation template. It is in a text file named template.yaml because I programmed it with the programming language YAML. It's up to you to choose YAML or JSON. We are viewing this text file in an IDE in the web browser named Cloud9. You can use Cloud9 or whatever you like. Now let's go over the template code. It was up to me to decide what goes in my template, and it's up to you to decide what goes in yours. Here I have exactly two resources. On line 3, an input, and on line 10, a channel. I wrote a piece of code on line 18 that tells CloudFormation that the channel refers to the input, and I did so with a CloudFormation function named reference. And that's what !ref stands for. It stands for the reference function. And this is why CloudFormation saves me time. It can remember how things relate to each other, so I don't have to put this all together by hand, which is much slower. So let's go over this code. Each resource has a type. Types are absolutely necessary to specify. On line 4, I specify the type for the input, and it's just a string, just like right here on line 11. Now, there are properties for each of these resources. Which property is possible depends on the CloudFormation template resource type. That's why the properties here are different than the properties here. It was up to me to choose the values for these properties, and it's up to you to choose the values for your template resource properties. Now, let's go over giving this code to the CloudFormation service on the cloud to execute. We can give this code to the CloudFormation service with a tool from Amazon named AWS. There, I just gave my template code to the CloudFormation service. And I did so with an action. And you want to remember the name of this action. This action is named create stack. Now I can use a different action to ask, hey, is it done yet? Because while creating a stack is quick, it is not instantaneous. So here I use an action describe stacks to say, hey, what's the status? And here it says stack status is complete. Now, there's a lot of information in that output. So one way to shorten that is to use a query, like I do down here, and say, hey, just get me the stack status. Look how much shorter that is.
That concludes the first demonstration. The key point there is CloudFormation code can save you time. It's much more efficient than creating things on the cloud by hand. So let's go over the unique capabilities of CloudFormation. This is why we use CloudFormation. The CloudFormation service is capable of transparency. When a user adds to the cloud with it, we can see exactly what we added. This is really neat. So transparency is a key capability. Now, a second capability that is really important is called reversal semantics. CloudFormation is capable of mutability. I can form, reform, or even reverse the formation of a cloud that I added. So select CloudFormation when reversal semantics are absolutely necessary. Now, finally, the third unique attribute of CloudFormation is that it is a service that executes code. We call this code semantics. We can give CloudFormation code to execute, and people can then read and write that code, and it's very specific. So select CF when code semantics are necessary. Code semantics reduce ambiguity, and code semantics make automation possible. Automation is very important. We can think of CloudFormation as a machine, and instead of people creating things, we can use this machine, and that can make us more efficient. So these are the key points for beginners to remember: transparency, reversal semantics, and code semantics. All right, let's go over what CloudFormation does over time when we execute code. In the first demonstration, we went over the action create stack. Let's look at create stack over time. In this example, this is a timeline of the action create stack, and this starts at T0. The rest of these are events that occurred by the CloudFormation service when it created my stack. In my stack were exactly two resources, one MediaLive input and one MediaLive channel. And there were little events here at T3, T4, T17, and T19 where CloudFormation notified me that it was creating resources on the cloud. So that's how I knew I was adding things to the cloud successfully. Now, CF is really quick. It took about 23 seconds to add one stack with two resources. And there weren't too many intermediate events. Just remember, this all doesn't happen instantaneously. Adding a stack and adding to the cloud happens over time. In this case, it took about 23 seconds, which again is much faster than doing things by hand. So let's go over reversal semantics. How do I clean up after I'm finished? I want to be able to add something, and I want to be able to reverse that addition and delete things. There is another CloudFormation action called delete stack. So with delete stack, a user can reverse the addition. Delete stack does the opposite of create stack. Delete stack very carefully removes what create stack added, and in fact, it removes them in reverse of the addition. Here in this timeline, the MediaLive channel is removed first because the channel refers to the input. After the channel is removed here in 23 seconds, CloudFormation then removes the input that the channel referred to at T25. By T38, the reversal is complete and the stack is completely removed from the cloud. It's pretty quick. Now, remember that the CloudFormation code added to the cloud and it created a graph. So we can kind of describe this as removing nodes from a graph one by one and doing so in the order of the graph, where the resources that are dependent are removed last and the resources that refer to each other resources are removed first. So let's go over another timeline. What happens when there's a problem adding to the cloud? We can call this a failure to add. And it's another really cool feature of CF. CF can safely reverse a failure that doesn't work out well. For example, say we try to add an inappropriate Media Live channel. It just can't be added to the stack because the code is problematic. The user adds the channel with the CloudFormation action update stack. And you want to remember that action, update stack. It's how we update a stack after we have added it with create stack. Now, Media Live didn't allow this channel to be added to the cloud because the CF code had a bug. CF responds to this failure by rolling back the update to the stack. So this is really neat. CF can reverse the failure, and by 32 seconds, the cloud looks exactly like it did before the failed update stack action. All right, now let's go over a second demonstration where I'm going to show you how to update a stack, and we're going to talk about a concept called drift.
This is the second demo for adding to the cloud, and we are going to reform the cloud after we added it. We are going to change the name of the one Media Live input in our CloudFormation stack, and we are going to do so with CloudFormation code. So let's take a look at the exact same template that we used to add the two exact resources to the cloud. We added one Media Live input and one Media Live channel. And I'm going to change in the code the name of the input from Spaceloop Video to Asteroid Video. So let me type that in. I'm going to change the name to Asteroid Video because I like it better. Now I have to give this code to CloudFormation. I'm going to do that with the AWS tool, and I'm going to use the action update stack. There, I just gave the template code to CloudFormation in the cloud, and it's going to change the name for me much faster than I could do by hand. Now I did something really important. I changed the code, and then I asked CloudFormation to change the resource. So that means my template and my resources are in sync. This is pretty good. This is also called a pure approach because it creates no drift. Drift is a measurement. Drift measures whether my code and my resource are together or apart. For example, it's up to me to decide how I change that name. I could change the name in other ways without changing the template code. For example, I could change the name in the console, or I could change the name of the Media Live input with a command, AWS Media Live Update Input. Now when I take these two other approaches without changing the template code, I create drift between the code and the resource. And it's completely up to you to decide which approach is best, one that is pure or one that it creates drift.
That concludes the second demonstration. All right, now let's go over reusing templates. This is another way to gain a lot of efficiency. We can share templates with other people. So how do I share a nice template? Well, there are two great services that make it easy to share: GitHub and Amazon S3. GitHub encourages reuse of templates. It is a source code repository designed for the public. GitHub encourages modification by users. For example, a GitHub user can copy a template, modify it, and then give back those modifications. S3 also encourages reuse. S3 has a much larger limit for the size of a template. A template may be up to 1 megabyte when it is hosted on S3. This is much larger than if you host the template on your own laptop. It's up to you where to store a template. You could store it anywhere you like. Just remember that S3 is a nice host for larger templates up to 1 megabyte. Okay, now let's dive a little bit more into the code semantics of CF. We're going to go over input. Now, when we share templates, we want to make it easier for users to customize how they add to the cloud with that template. We can do that by changing a template to accept input. This is called parameterization. I'm going to now demonstrate parameterization with template parameters.
Let me show you how to save some time by taking a template and making it more reusable. That way, users can customize how they add to the cloud. Here is the template, which had 2 Media Live resources. And I have changed this template to accept input from the user. I have done so by adding parameters. This is called parameterization. On line 2, I have defined a new CloudFormation template section named parameters. And on line 3, I have named one parameter MP4 URL. On line 18, I used that parameter. I wrote a little code to instruct CloudFormation to take the value from the user's input and place it here as a URL. Now let me show you what it looks like when CloudFormation accepts user input. Here is the CloudFormation action create stack, and it has a little bit more. There is a parameter key and a parameter value. This is how I give CloudFormation input. Now it's up to you to add parameters and determine whether they should be required and absolutely necessary, or they should be optional. Here on line 5, I have added a parameter named input name, and it's optional. It's optional because on line 7, I've given a default value. If the user does not provide input, CloudFormation will use the default. There's another way to also make parameters less of a hassle, and that is to host the value of the parameter on the cloud. Here is a parameter named stream key on line 8, and it is hosted on the cloud by a service named AWS SSM. That stands for AWS System Manager. This saves me a lot of time because when I ask CloudFormation to take action like create stack, CloudFormation will automatically get the value from Amazon System Manager for me, and that will save me a lot of time.
That concludes the third demo. Now let's go over another feature of code semantics. We can ask CF to generate output when we create a stack. So let's go over stack output. When we ask CloudFormation to create output for a stack, we can call this introspection. So here's a demo of introspecting a CloudFormation stack.
This is the fourth demo in adding to the cloud. We can make a CloudFormation stack more reusable by adding outputs to a stack. Now it's completely up to you whether a stack should or should not have outputs. A CloudFormation output can make a stack more reusable because we can use these outputs in other places in the cloud. So let me show you the code for creating outputs. Here is the template which we use to add 2 media live resources to the cloud. I have added a template section named outputs to it. And in this, I have code for 2 outputs, one named input ID on line 132, another named channel ARN on line 135. When I add outputs, this is called introspection because I'm kind of looking into the stack. Now let me show you what these outputs look like. Remember, we create a stack with the action create stack, and we get information from a stack by a different action named describe stacks. Let's use describe stacks. Here we go. Here are the outputs that CloudFormation remembers for us. And this saves us a lot of time when the cloud remembers it for us. Here we have a number here, which is the input ID, and we have an ARN here, which is the ARN for the channel. Now let's quickly go over how I created these outputs. Here on line 134, I have the code to create this number, and I use the CloudFormation function reference, and I refer to the media live input. That's how I get this number. Here on line 136, I have a piece of code which gives me the ARN, which stands for Amazon Resource Name, for the Media Live channel. And I use a different function which I am introducing to you named getAttribute, or shortened here as getAtt. And I give the getAtt function my Media Live channel in my template, and I append period ARN. And that's how I get the ARN as the output value for my channel ARN output.
So that concludes the fourth demonstration. Now let's go on to another topic for CF, and this is composition. How do we write really nice templates? Well, there are tools that we can use to make template writing easier. So that way we can very efficiently add to the cloud. These tools do something really important called validation. And validating a template before we give it to CloudFormation can save us a lot of time. For example, remember the timeline of the failure to add? That's lost time because CloudFormation had to roll back something when there was an error in the template code. Validation can save you time because it can catch those errors in the code before you give it to CloudFormation. Here's the fifth and final demonstration about validation.
This is the fifth demo in adding to the cloud. It can be really important to be efficient and add code that is valid. And this is really common when we start with a template. We'll want to update it. There is a means of checking a template before we ask CloudFormation to execute the code in it. This process is called validation. Now it's up to you to choose which tool you use to validate a template. Let me show you one of my favorites. I use a tool called CFNlint, and it's available for free, and I install it with the pip package manager with this command, pip install CFNlint. Now, here in my template, I am adding a third resource. I want to add a second Media Live input to the cloud. And let's ask CFNlint if my code is okay. Look, it found the problem on line 133. So let's look at what's going on. On line 133, there's a property named typo. Oh, that's wrong. Now it's up to me to fix this. And I know that a Media Live input data type in CloudFormation has a property named type. So there, I fixed it. And now I'm going to run CFNlint a second time, and it passes. Now this is going to save me a lot of time, because when I give this template to CloudFormation with the action update stack, and remember we can update a stack with update stack, it will work. It won't roll back because of a typo. And that can save me a lot of time.
That concludes the fifth and final demo. Now let's go over a few other points of composition. A great question to ask is, how do I design a stack? Well, the solution is to think of a stack as a graph of resources. Resources can be independent of each other, but resources can also refer to each other. It's really up to you to design this. Now, remember, this is really neat because CloudFormation can answer a simple question like, what depends on this resource in the cloud? This question may come up a lot over time when you have to maintain your cloud. So CloudFormation also has a benefit where there are many parts of the cloud which you can quickly reuse. And you can add these parts to your cloud quickly with CF. So where do you find these resources to add? Where's a list of them? Well, There's a list on docs.aws.amazon.com. You want to go to the Management and Governance section and then look for the CloudFormation service. This service has a user guide, and this is where you can find the list of resources that you can add to the cloud. So you don't have to build these things yourself. You can just reuse them because they're already built for you. Here's a QR code you can scan that will take you to that user guide webpage. So, for example, Amazon has many media services on the cloud, services like Elemental Media Live and others. CloudFormation can add these to the cloud for you very quickly because Amazon's media services are compatible with CF. All right, that concludes our discussion about CloudFormation. Let's review the key points about CloudFormation. CloudFormation is code. CloudFormation is a service. The code for CloudFormation is put in a CloudFormation template. That template has a structure where that structure is resources, parameters, and output. CloudFormation code can be written in 2 different languages, JSON or YAML. Let's review the CloudFormation service. It hosts on the cloud stacks. There are actions that the CloudFormation service can take, such as create stack, update stack, delete stack, and describe stack. We also discussed one media service, Elemental Media Live. That's the service that streamed the video to YouTube. We went over 2 types of resources that Elemental Media Live hosts, an input and a channel. And finally, one thing to touch on is there are limits to CF code. One stack can have no more than 500 resources. Our stack was tiny, it just had 2. There is an upper limit to 1 stack. A single stack can have no more than 200 input parameters. A CloudFormation stack can take input, but there are limits. Also, there is a limit of 200 outputs in 1 stack. So keep that in mind when you design your templates for reusability with outputs. So this concludes the discussion about CloudFormation for beginners. If you're excited about CloudFormation, there are more advanced features of it that you can learn about in the future. These advanced CloudFormation ideas fall into 2 categories, reusability and composition. It's a very long list, and I won't go over each one, but this is what is ahead of you if you start to use CloudFormation to add to the cloud quickly with code. And here's a map of the advanced ecosystem around CloudFormation. There are many tools out there, and it's up to you to pick which ones you like. So we're done. This concludes the presentation, Adding to the Cloud for Beginners. And once again, we had 4 key points that make CloudFormation very amazing: transparency, reversal semantics, code semantics, and reusable parts. Thank you very much. My name is Alex. My company's name is Spicy Key. And thank you for watching this Reskill session.